question 1C, you can see that I've started off by highlighting the information that I think is most important. We've got the equation, which is also always very important, 3% biomass of FeS2. Calculate the volume of gas in meters cubed produced by combustion of 1 tonne of coal, 50 degrees and 100 kilopascals. Give your answer to an appropriate number of significant figures. Okay, so firstly, an appropriate number of significant figures means that it's 3 significant figures. This is the first time I've ever seen them use the word appropriate, but it is always 3 that they would expect you to use unless it's quoted otherwise in the question. Because the question's giving us non-standard temperature and pressures, we know that we need to use the PV equals nRT equation rather than the standard N24 equation. The question's also asking us to figure out what the volume is to calculate a volume. Now that means we're going to need to rearrange our PV equals nRT to make V the subject of the equation, which gives us nRT divided by P. Now, this is the information that I have. I have R8.314, which is standard. N, I've got that as my I need to know. 323 is my temperature taken from the question, which was a temperature of 50 degrees and converted into Kelvin. And then down here for my P, I've got my pressure, and I've also represented and recognised that I needed to convert it into pascals from kilopascals. So there's a few things that we've needed to do there before we've even entertained the idea of answering the question. Now, from there, we needed to know the number of moles. So the number of moles of gas is the number of moles of SO2. I've got that from the equation. Now that might seem straightforward, but just to recognise for future questions, it is potentially possible that both of the products could be a gas. So looking at the state symbols and recognising what falls into the gas category and what doesn't is important. So my number of moles of gas is equal to my number of moles of SO2. My number of moles of SO2 is equal to what? How do I find out that information? Well, work backwards. I need to know the number of moles of SO2. I can figure that out if I know the number of moles of FeS2. I have the data to calculate this. So in order to calculate my SO2 moles, I use the information that I have for my FeS2. Now, I use my N equals M over M equation. I have only got percentages, so I do need to use my percentage to calculate my actual mass. So 3% of 1 tonne, and my big M, my molar mass, is going to be the molar mass of FeS2. So 3% of 1 tonne divided by the molar mass of FeS2 gives me my number of moles of FeS2, which is equal to 250 moles. If I look then, my number of moles of FeS2 to my number of moles of SO2, the stoichiometry, which I've taken from the equation, 4 to 8, i.e. 1 to 2, means that I have got 500 moles of my SO2. I now have the information, I believe, to complete the equation. We rearranged it and made V the subject. We needed the number of moles, which we now have, my 8.3 and my 323, that being standard and that being my temperature converted into Kelvin, and my P on the bottom, which is my pressure converted from kilopascals into pascals. If I follow all of that through, my answer is 13.4, and we've already got it in meters cubed, so I don't need to do any other conversions to get it into the unit that is asked for in the question, and I know that because it's indicated down here right at the bottom.